These are notes for section 7.4, factoring using a greatest common factor. So in the first three sections of chapter 7, we have been talking about how to put polynomials together, whether we added them together, subtracted them together, or multiplied. We have been taking polynomials and putting them together by adding, subtracting, or multiplying. Well, 7.4, the other math operation, add, subtract, multiply, and now we're going to be talking about dividing polynomials. Well, instead of calling it dividing, we call it factoring. It's the same difference, though. The factors of 6, 2 times 3 is 6. 6 divided by 2 would be 3. 2 and 3 are factors of 6. And our first method of factoring, as it says here, is something that we should be familiar with, the GCF, the greatest common factor. And this is something that we should be familiar with from probably grade school or somewhere in there. The GCF is simply the biggest number that will go into a set of numbers. So if we're looking at the number 24 and 16, what number will divide into 24 that will also divide into 16? Now you could say 2, and 2 is a common factor. 2 goes into 24 and it goes into 16. But if we're talking about the greatest common factor, the biggest number, well, that number would be 8. 8 is the GCF. Between 30 and 50, what biggest number will go into 30 that will also go into 50? That would be 10. 10 would go into both of those. And between 13 and 17, what number will divide 13 that will also divide 17? Now you might say, well, there are no numbers. Well, there's always a number that will divide it, and that number would be 1. So yeah, I suppose you could say there is no GCF, but if that's the answer, then the GCF is 1, because you can divide any number by 1. So in Algebra 2, which is where we're at, we got to talk about the GCF of variables. This gets a little bit more tricky. When we're looking for the GCF of variables, and again, we're still looking for the greatest common factor, that is going to be the smallest exponent that each same variable has in common. For example, on number 4, in this monomial, x to the third, y to the fifth, in this monomial, x squared, y to the eighth, both of these terms have an x in it. This term has 3 x's, and this term has 2 x's. So the GCF would be x squared. They can share at most 2 x's. This first term has 3 x's to share. This second term has 2 x's to share, so they can only share at most 2. They can share 2 together. It's the smallest exponent that each same variable shares. Now, again, they both have a y in it. Y to the fifth, y to the eighth. Now I'm looking for the smallest exponent that each same variable shares. Excuse me, I got to sneeze. So that would be y to the fifth. X squared, y to the fifth would be the GCF. They both share an x. X squared is the smallest exponent. They both share a y. Y to the fifth is the smallest exponent. On our second example, between xy to the fourth and x to the fifth y squared, z. They both share an x. X to the first is the smallest. They both share a y. Y squared is the smallest. They both do not have a z, so the GCF is xy squared. I'm looking for the smallest exponent between the same variables. So x squared and x to the sixth, x squared. Y and y to the fourth would be y. Z to the third and z would be z. So x squared, yz. So down below here, when we get in the notes, what we're going to do is take both concepts here. The GCF of numbers, we should be familiar with these, and what we just discussed, the GCF of variables. Sorry about that. So again, in the first 3 sections, we talked about adding, subtracting, and multiplying polynomials. That's putting stuff together. Now what we're going to do is factor these polynomials by pulling them apart by factoring using the GCF. And in order to factor using the GCF, the first thing that we have to do is write the GCF, which we just talked about above. We're going to make a set of parentheses, and then we need to fill in these parentheses. For example, on number 1, between this term and this term, I have 2 and 2, so my GCF between the numbers would be 2. Looking at the variables, I have an x and a y. They don't share any common variable, so there is no GCF of the variable. So after I find my GCF, which I just did, step 1, find and write the GCF, now I need to make a set of parentheses. So I'm going to make my front set of parentheses. Now I need to work backwards, because whatever I put in here in the parentheses, when I multiply, I would need to end up right back where I started at. So you have to ask yourself, and this is the working backwards part, what times 2, what could you put here that when you multiplied it by 2, you would have 2x? Well, that would be x. Plus, because it's a plus sign. What times 2 could you put here in the second spot that when you multiplied it, you'd end up with 2y? Well, that would be y. And this is our first factoring problem. So I have undone the multiplication, or I have pulled apart this binomial in number 1. And you can check to make sure it's correct by distributing the 2 through, and you end up with exactly where we started. On number 2, between 12 and 8, what will go into 12 that will also go into 8? Well, that would be 4. 4 goes into 12 and 8. They both have an a to the 5th, a squared. So they both have an a, and the GCF of the variables would be a squared. 4a squared is the GCF. Once we have the GCF, I make my first set of parentheses, and I have to ask myself, what times 4 would give me 12? Would that be 3? 3 times 4 is 12. I need a to the 5th. I have a squared. So how many more a's would I need to put in this first spot that if I were to multiply, I could end up back at a to the 5th? That'd be a to the 3rd. Minus, because it's a minus sign. What times 4 would give me 8? 2. I need a squared. I already have a squared, so I don't need any more a's inside the set of parentheses. So the factored answer would be 4a squared, parentheses, 3a to the 3rd minus 2. Now let me quickly touch on this point one more time here. 4a squared parentheses. And what I'm trying to end up with is 12a to the 5th. So I think we all see that 4 times 3 is 12. Easy enough. Now we need to figure out how are we going to end up with a to the 3rd here. Well, this is where we spent so much time in chapter 6 talking about. I have a squared. That's this right here, a squared. A squared times a to the what would give me a to the 5th. That's what I need to figure out. I need to figure out what number, what exponent do I need? And I'm getting these exponents from a to the 5th. That's in the problem. A squared, that's my GCF. And a squared times a to the 3rd would give me a to the 5th. So I know it's 3a to the 3rd. I got a couple more for us. On number 3, between 6 and 15, 3 goes into both of those. They don't share any common variables, so 3 is the GCF. What times 3 is 6? Would that be 2? I need x squared, so I need x squared. Plus, because it's a plus sign. What times 3 is 15? That would be 5. I need a y, so I need a y on the inside. On number 4, between 21 and 15, I could factor out a 3. 3 would go into both 21 and 15. This first term has an x, the second term does not, so I can't pull an x out. Both of these have a y in it, so I could pull a y out. 3y is the GCF. What times 3 is negative 21? Well, that's minus 7. I need x squared, so I need x squared. I need y to the third. I already have y, which means I need y squared. Y times y squared would be y to the third. Minus, because it's a minus sign. What times 3 would give me 15? Would that be minus 5? And I need y here at the end, and I already have y here on the outside, so that's my factored form. 2 more. Between 6, 18, and 24, what number will go into each of those? That would be 6. They all don't have an x, so I cannot pull an x out. What times 6 is 6? That's 1. X to the third minus what times 6 is 18? 3. X squared plus what times 6 is 24? That'd be 4. And on the last one, between x to the fifth and x to the fourth, they can share 4 x's, x to the fourth. What times x to the fourth is x to the fifth? Well, that would be x. Minus, because it's a minus sign. What times x to the fourth is x to the fourth? Would that be 1? Hopefully that helps for section 7.4. We have a couple more videos in this section upcoming, and I'll see you on the next one. Thanks. Bye.